and welcome. And in this video, we are going to be focusing on factoring out the greatest common factor. So we're going to be factoring out the GCF. Now, before we get to that, I want to go over something that you should all be very familiar with, the distributive property, right? Multiplying. So in this problem, we would have 4 times the quantity of 6x minus 5, and we would distribute the 4 into that quantity. So we would do 4 times 6x to get 24x. We do 4 times negative 5 to get negative 20, and that would be our final answer. So remember, that's a distributive property, and that is multiplication. Now, a lot of the times when we get to higher level mathematics in Algebra 1, Algebra 2, and so on, it actually helps a lot to undo that multiplication, to, in essence, work our way backwards from this step to this step. It might seem counterproductive, but it's actually extremely useful and beneficial to use in solving all sorts of quadratic and polynomial equations. You can also use it for rational. It's useful in a lot of different places. So that's what I want to cover. So basically, I want to go from 24x minus 20 back to this. But how would we do that? Well, factoring you can think about as undoing multiplication. It's essentially kind of division. So the way that we do this is we look at all the terms in our polynomial. So in here, I have 24x minus 20. And what we want to think about is what is the greatest common factor of each number. Essentially, what is the biggest number that goes into both of these, 24 and negative 20? Now, some of you might be able to just do that very quickly off the top of your head. If not, we can kind of make a list of our factors. We can get 24 by doing 1 times 24. We can do 2 times 12. We can do 3 times 8. We can do 4 times 6. And that's about it. And to get to 20, I'm not going to focus on a negative for now. I can do 1 times 20. I can do 2 times 10. And I can do 4 times 5, right? Well, the greatest common factor is the largest factor that goes into both of these. So although they both do have factors of 1, which lo and behold, every number has a factor of 1, and they do have a common factor of 2, the greatest common factor is actually the 4. Both of these share a factor of 4, and that is the largest number that goes into both of these numbers. So that is what our greatest common factor is, and that should look familiar because that was a number that was outside of the parentheses over here. So this is the first step to factoring out the greatest common factor. You got to know what the greatest common factor is. So I would factor out the greatest common factor of 4. And now what I do is I divide each of these terms by that factor. So I divide 24 by 4, and well, that's 6. And there was an x left over, so I'm going to bring that x back down. And then I do negative 20 divided by 4. Well, that is negative 5. And there we go. That is how we factor using the greatest common factor. Now, I do want to cover a couple more examples that kind of spice it up a little bit, okay? And now, although it is very useful to visually see exactly what all those pairs are, ultimately the end goal is to not have to list this out. You should know the factors of any number I throw at you, okay? So make sure that we know our times tables. So let's take a look at a couple more problems. So we have a new example here. We have 27 minus 9y. And what we want to do is we want to factor this. So I'm going to go ahead and list out what the common factors are. For the next problem, I will not. So for 27, I can get 27 by doing 1 and 27. And I can do 3 and 9. And that's about it. That's all I can really do. And then for 9, I can do 1 and 9. And that's all I can do. Well, notice they do have a common factor of 9. Both of these are divisible by 9. So 9 is a factor of each of these, and it's the greatest common factor. So I'm going to factor out the 9, okay? I'm going to factor out the 9. So now I divide each of these terms by that 9. Well, 27 divided by 9 is 3 minus, and 9y divided by 9 is 1y. So all that's left in this place is a y, and this would end up being our final answer. If you want to double check your work, if you want to double check to make sure you did this correctly, all I need to do is multiply this 9 back out. And if what you get is the original problem, you've done it correctly. So if I multiply this 9 times 3 is 27, 9 times negative y is negative 9y. Those match, that means it is correct. So you can always do that to double check your answer. Okay, now let's take a look at one more. And for this one, I am not going to make a list of factors, so I recommend you try this on your own first. Now I have 10x plus 18. So I'm thinking, what is the greatest common factor? Well, the greatest common factor, 10 is just like 2 and 5, and 18 is 2 and 9, and 3 and 6. So the greatest common factor is 2. So I'm going to factor a 2 out. So I'm factoring out a 2. Now, when I factor out a 2, I divide each of these terms by 2. So 10x divided by 2 is 5x. And 18 divided by 2 is 9. So this would end up being our final answer. And once again, if you want to double check your work, just go ahead and multiply that back out. If I multiply that back out, 2 times 5x would be 10x. 2 times 9 would be 18. They do match. That means I did it correctly. So this would end up being our final answer. Now I want to take a look at just one more problem that involves a little bit more variables. So let's go ahead and take a look at this last problem. So for this last problem, we have 32x squared plus 20x. Now, this is going to involve kind of two pieces of the greatest common factor. The first is just, okay, what is the greatest common factor between 32 and 20? We have quite a few different numbers that go into both of those. 2 goes into both 32 and 20, but so does 4. So 4 is going to be part of our greatest common factor because I can divide each of those by 4, and that's the largest number that is divisible. That is a factor of 32 and 20. Now the next part is, notice how both of these have the variable x. That means that they actually have a common factor of x. In fact, well, there's 2 x's here because that's x squared, and there's 1 x here. So they have an x in common. So I'm actually able to take out an x. So our greatest common factor would be 4x. Now, if you really wanted to, you could list out all the pairs for 32 and 20. But you could also list out, well, x squared is x times x, and x is just x. So notice that they do have 1x in common. So that's another way I can determine how many variables I can actually take out. So the greatest common factor is 4x. So now I do 32 divided by 4. Well, that's 8. And x squared divided by x is just x. Basically, the way you can think about it is, well, you had 2 x's, you're taking one of them away, so 1 is left over. So that's how I get 8x. Plus, well, 20 divided by 4 is 5. I had 1x, I took it away, so there are none left. So this would end up being our final answer. And once again, if you want to double check, feel free to double check. If I were to multiply that out, 4 times 8 is 32. X times x is x squared. 4x times 5 would be 20x. That's exactly what our original problem was. So that means that we factored it correctly. And that is factoring out the greatest common factor. Now, this should always be the first step for any factoring problem. No matter what type of factoring problem we're being thrown, the first thing we should always check for is the greatest common factor. So make sure that we are very comfortable doing this. In the next couple videos, we're going to be factoring all sorts of different problems using difference of squares, perfect square trinomials, and factoring quadratic trinomials. And then in future videos, we'll also be covering factoring polynomials, which really spices things up and makes it a lot more fun. So if there's any questions, please make sure you let me know. I hope this video was helpful, and I look forward to seeing you guys in the next couple videos.